Hello everyone. So after a long time again I came with a video related to JEE mathematics, in which we are going to discuss about theory of equations. So in this first video, part 1 video, so these are the topics that we are going to cover. So one by one we will go in detail. So let us see what are the basics of this theory of equations. In our high school level, we came across polynomials. What is meant by polynomial? We know that a polynomial, so we are discussing the concept of theory of equations. So under this topic, theory of equations, first one, a real polynomial. What is meant by real polynomial? So we came across a polynomial definition or polynomial general form. The same general form we are going to discuss in real polynomial also. Why we are calling it as real polynomial? Because all coefficients in the polynomial are real numbers. At the same time, the variable x, whatever the variable we are mentioning in the polynomial, is also a real number. So the general form of polynomial, let us name that polynomial as f of x, or you can take p of x also. So I will take p of x. P stands for polynomial. P of x is equals to a naught a1x a2x square and so on an x power n. Here, what are the real polynomial coefficients? Real coefficients. Here a naught, a1, a2, a3 and so on an. They all belongs to real number. That means they are called as real coefficients. Real coefficients. And the variable x, whatever we have written the polynomial in terms of variable, the x is also a real variable. It is a real number. Example. What is the example of a polynomial? That to a real polynomial. So we have 2x power 4 plus 3x cube plus 4x square plus 2 root 3x plus 5. It is a polynomial which is called as real polynomial. We can see the coefficients here: 2, 3, 4, 2 root 3 and 5. These are real coefficients. Similarly, we have complex polynomial. What is the meaning of complex polynomial? The same general form we can consider here. P of x is equals to a naught, a1x, a2x square and so on an x power n. Here the coefficients a naught, a1, a2, whatever we are considering as coefficients, they are called as complex coefficients. They belongs to complex numbers. They belongs to complex numbers. That means they are complex coefficients. Similarly, the x is a complex number which is varying, or variable complex number. So x is a varying or variable coefficient, or varying complex number. Example: 3 minus 2y x square plus 4x plus 3. It is a polynomial which is called as complex polynomial. Why we are calling it as complex polynomial? Because the coefficients you can see. What is the coefficient here? 3 minus 2y, an imaginary number. 4, again a polynomial coefficient 4, 3. Because it is having the polynomial coefficient as complex numbers, we call it as complex polynomial. Next, after this, we have a rational function. Rational expression or rational function. What is meant by rational number? Already we have gone through the rational number definition in the high school level. A number which is written in the form of p by q. Similarly, here also the rational number is a rational expression is written in the form of p by q, where the denominator q of x is a non-zero constant. So the next one is a rational expression or a rational function. What is meant by rational function? If any function, that means if any rational number, rational polynomial or a polynomial is written in the form of p of x by q of x, where this q of x is not a zero number, zero. That means it is a non-zero constant. It is a non-zero constant. Example, x square minus 5x plus 6 by x minus 3. So, on dividing this polynomial with this linear polynomial, we are going to get one quotient. One quotient. That is a polynomial. That means that polynomial can be represented in the form of a fraction, a rational number. That means we can make a note point here. Every polynomial can be written as rational function or rational expression, but converse is not true. Converse is not true. What is the meaning of converse is not true? The rational function cannot be written in the form of polynomial function. Example, 1 by x or 1 by x plus x, we can call it as rational function, but it cannot be considered as polynomial. We cannot write it as a polynomial because we know the definition of polynomial in the school level. So we can, when you see the highest power, that means degrees of each and every term, powers of each and every term, so they are going to be the whole numbers. We are not going to have the negative power. So rational expression or rational function nothing but a polynomial which can be written in the form of p of x by q of x is called as the rational function or rational expression, and q of x, that is a condition, main condition, q of x is a non-zero constant. So this is one example. So whatever the quotient we are going to get, so we can get a polynomial. That means a rational number can be written as polynomial, a polynomial can be reversed like this. But at the same time, in some cases, rational function cannot be written in the form of polynomial. Example, this one. So next one. The next one is a degree of a polynomial. What is the meaning of degree of a polynomial? So we know very well that what is a degree. So whenever you take the terms, among the terms whichever is the highest degree, so based on that degree, highest power, we can consider the degree of the polynomial. Same thing here also. So if f of x is a polynomial, f of x is a polynomial where it is having the degree as, so let us consider the polynomial f of x is equals to a naught, a1, x, a2, x square and so on, an x power n. So according to this, which one will be the degree? So based on this n value, we will decide the degree. So think that n is the highest degree here. So n is the degree of the polynomial. But condition that this coefficient an should not be 0. Example, 3x power 4 plus 3x cube 2x square plus 4x plus 6. It is a polynomial. So what is the degree of this polynomial? Among all the terms, what is the highest degree? So 4 is the highest degree. Suppose if this term is going to be 0, then we will not get x power 4 term. That means the next term is going to be considered as that means next degree power, variable power is considered as degree. So that means, so for making the degree of the polynomial, for deciding the degree of the polynomial, so there must be the coefficient beside it. So without this coefficient we cannot decide. So here what is the degree of the polynomial? Degree is 4. Based on this degree of the polynomial, we have several types of polynomials. So based on degree, if the degree of the polynomial is 1, then we call it as linear polynomial. What is the linear polynomial? What is the standard form? What is the general form? The general form of linear polynomial is ax plus b. Ax plus b. And when we go for a graphical representation, since it is a linear polynomial, the graph is going to be the straight line. The graph is going to be the straight line. Linear equation, line. So straight line. Similarly, if the degree of the polynomial is 2, then we call it as quadratic polynomial. And the general form is ax square plus bx plus c. And what is the graphical representation? The graphical representation of quadratic polynomial is going to be parabola. So U-shaped curve. So very important concept regarding to polynomial, quadratic polynomial. After this we have quadratic equation concept in the next video. So we are going to cover that concept in detail. So as of now we are discussing about polynomial basics. So if the quadratic polynomial, that means if the degree of the polynomial is 3, then it is called as cubic polynomial. So what is the general form? Ax cube plus bx square plus cx plus d. So what will be the curve? So the curve will touches the x-axis at 3 different points. So very important point. So I said that the curve of this cubic polynomial is going to touch x-axis at 3 different points. So for making the x-axis to be intersected with this curve, so we should have the real variables, that means real values of the x. If we don't have the real values, we cannot decide the values. Okay, so we can say that, supposing that this is the curve, so it is touching the x-axis at 3 different points. So if the highest degree is 4, then we call it as biquadratic polynomial. So what is the meaning of biquadratic polynomial? So the highest degree is 4. So ax power 4 bx cube plus cx square plus dx plus e. This is going to be the general form, and the same whatever the concept we have followed for cubic polynomial. That means it is touching the x-axis at 3 different points. Same thing, biquadratic polynomial graph also touches the x-axis at 4 different points. So here also the same point, for x-axis to be intersect with this parabola, that means whatever the curve. So we must have real values, real numbers. So that is going to be the brief introduction about the linear polynomial types. And what is polynomial equation? What is a polynomial equation? If any polynomial f of x is going to equate to 0, if it is going to be equated to 0, then we call it as polynomial equation. Polynomial equation. Similarly, as we have types of linear polynomial, if this linear polynomial is going to be equated to 0, we call it as linear equation. Here quadratic polynomial equated to 0, quadratic equation. Cubic polynomial equated to 0, cubic equation. Biquadratic polynomial equated to 0, biquadratic equation. So overall, these are the family members of polynomial equation. So we can call it generally polynomial equation. So for this polynomial equation, we have to find out some roots. What is the roots? And before going to roots, we have the very important concept called as fundamental theorem of algebra. What is the fundamental theorem of algebra? It states that any polynomial, suppose think that I have a polynomial f of x as 4x cube plus 3x square plus 6x plus 7. Fundamental theorem of algebra says that if f of x is a polynomial of degree n, but here degree is 3. So if the degree is n, then the number of roots is going to be roots, n roots. That means if the degree is 3, then the roots are 3. If the degree is 2, 2 roots. If the degree is 4, 4 roots. Understood? So fundamental theorem of algebra says that if f of x is a polynomial of degree n, then it has n roots. N roots. And among those n roots also, we will be having real roots as well as non-real roots. This is the statement. So fundamental theorem of algebra says that if f of x is a polynomial of degree n, it has variables of real or non-real in nature. So this is the fundamental theorem of algebra. Next, roots of equation. How to find out the roots of equation? Any polynomial equation. So how to find out the roots? What is meant by roots? Roots of an equation. Roots of an equation, polynomial equation or any other equation. A root of an equation is nothing but a value of x or a value of variable which satisfy the equation. What is the meaning of satisfying? Suppose if I take the example of x square minus 2x plus 1 equals to 0. It is an equation, polynomial equation. Since it is degree 2, it is called as quadratic equation. Now roots of an equation. What is the meaning of roots of an equation? If I am going to place any value in the place of x, if I substitute x value by someone, so then this entire polynomial left hand side values is going to be 0. That is the meaning of satisfying. So if x is equals to 1, let us see what will happen to this equation. 1 square minus 2 into 1 plus 1. 1 square 1, 2, 1. 1 plus 1, 2, 2 minus 2, 0. It became 0. It equated to 0. So that means x is equals to 1 is going to be the root of an equation. X is equals to 1 is going to be the root of an equation. Let us take one more example. So we will take x cube minus 6x square plus 11 minus 6. X cube minus 6x square plus 11x minus 6. So equals to 0. So we have to find out the roots of an equation. Now here, since it is a cubic equation, so directly we have to find out the equation, which is not possible directly. So for finding the root of the equation, some clue must be there. So here we have to make a note point that if any polynomial is given, any polynomial, not only cubic polynomial or any polynomial is given, if sum of all coefficients if sum of all coefficient is 0, then x minus 1 is a factor, or x is equals to 1 is the 0 of that polynomial or root of that equation. Understood? Sum of all coefficient is going to be 0. Then x is equals to 1 is the root. Since we are discussing about equation, we call it as root. X is equals to 1 is the root of an equation. Suppose think that I have to find out the roots of an equation. According to fundamental theorem of algebra, how many roots it will be having? So it will have 3 roots because the degree is 3. Now, since we have this condition, sum of all coefficients. What is the coefficient here? 1 minus 6 plus 11 minus 6. 1 minus 6 minus 5 minus 5 plus 11 6. 6 minus 6 0. So that means I can consider x is equals to 1 as one root. Still how many roots I have to find out? 2 roots. So here I can follow to reduce this cubic equation into quadratic equation. That means a degree which is lesser than this one. I have to use Horner's method of synthetic division. Horner's method of synthetic division. So what will be done in this process? So in this reducing the given equation into of degree lesser than the given equation, so we have to consider the quotient first. 1 minus 6 11 minus 6. Since I know the one root of this equation, how? By using this note point. What is that note point? Sum of all coefficient is going to be 0. Then x is equals to 1 is the root. Now x is equals to 1 I will consider. I have to make one term as 0. So in cubic polynomial how many terms are there? 1, 2, 3, 4 terms are there. So I have to reduce the degree. That means I have to reduce one term. I have to make one term as 0. So I will keep 0 here. Add these two terms. 1 plus 0 1. 1 into 1. I have to multiply whatever the result I got after addition. Multiply with the root. 1 into 1 1. Minus 6 plus 1 minus 5. Again minus 5 into 1 minus 5. 11 minus 5 6. 6 into 1 6. So I got these two terms as 0. Now whatever the terms I have left with are nothing but this is the last one, constant term, this is the x term and this is the x square term. So I can write it as x square minus 5x plus 6 equals to 0. Now if you factorize this one, what are the factors we are going to get? X minus 3 and x minus 2 are the factors. Then x is equals to 3, x is equals to 2. So how many zeros we got totally? X is equals to 3 comma 2 and here x is equals to 1. Totally 3 zeros are 3 roots of the equation. 3 roots of an equation. So this is how to find out the roots of an equation. Now these are the roots of the equation, and whatever the roots we have 1, 2 and 3 together, it is called as solution set of an equation. Solution set of this equation. Solution set. Roots of equation and solution set. If you take these roots together as a set, as a group, we can call it as solution set. In JEE level problems, what kind of questions you can come across? Basics. So you can see the question on the screen. The same question I am going to solve here. The question is like this. The question given here is, let f of x be a quadratic polynomial satisfying f of 2 plus f of 4 equals to 0. If unity is one root of f of x equals to 0, then find the other root. So he said that f of x is a quadratic polynomial. F of x is a quadratic polynomial, and condition they have given f of 2 plus f of 4 equals to 0. And among not only that f of 2 plus f of 4 equals to 0, but they have given that if one root is a unity. What is the meaning of unity? Unity nothing but x value is 1. That means x is equals to 1 is one root of that quadratic equation. If x is equals to 1 is going to be the root, then can I say that x minus 1 is a factor? Yes, we can say that x minus 1 is a factor. Now, f of x value we have to decide. F of x is nothing but now x minus 1 into, I have to get a quadratic equation. This is a linear polynomial. One more linear polynomial I have to multiply so that I can get the quadratic polynomial. So x minus 1 into x plus ax plus b equals, this is the quadratic polynomial. So this is a quadratic function now. Now, what is the condition they have given? F of 2 plus f of 4 equals to 0. Individually, find out f of 2. F of 2. What is f of 2 here? 2 minus 1 a into 2 plus b. 2 minus 1, 1. 2a plus b. F of 2 value is going to be 2a plus b. Next, f of 4 you have to find out because they have given f of 2 plus f of 4. So individually I am finding the values of f of 4 and f of 2. So 4 minus 1 a into 4 plus b. So 3. So what will be the value? 3 4s are 12a plus b. So f of 4 value. But they have given f of 2 plus f of 4 equals to 0. So what is f of 2 here? 2a plus b. Since f of 2 plus f of 4 equals to 0. So 2a plus b, 12a plus b equals to 0. The next step, 14a plus 2b is equals to 0. Then 14a is equals to, or you can take b value here. So 2b is equals to minus 14a. Then b is equals to minus 14a by 2. Nothing but b value is minus 7a. Am I correct? 14a, b plus 3 4s are 12. Yes, here 3b. I forgot to take 3b. So 3b nothing but here 4b I will get. So 2 2s, 2 7s. So b is equals to minus 7 by 2a. Now substitute this value in the given condition, whatever the condition we have discussed. So f of x is equals to x minus 1 into ax, b value is minus 7 by 2a. Since he has given that it is a quadratic equation, I can equate it to 0. X minus 1 into ax minus 7 by 2a equals to 0. Here x value we know already, x value is 1. So what about one more root? So ax minus 7 by 2a is equals to 0. Then x minus 7 by 2 equals to 0. Then x is equals to 7 by 2. So we have quadratic equation here where x is equals to 1 is one root. In the question itself given unity is the root and the one more root is x is equals to 7 by 2. Let us discuss one more example. So if they have given some typical conditions along with the values. So we can see the question on the screen. They are given that a polynomial in x of degree 3 vanishes when x is equals to 1 and x is equals to minus 2 and has the values 4 and 28 when x is equals to minus 1 and x is equals to 2 respectively. Then find the value of the polynomial when x is equals to 0. So what type of polynomial here? Degree 3 polynomial. So if the degree 3 polynomial is given, so highest degree will be 3 factors will be there, sorry, 3 roots will be there. Among those two roots, what they have given? X is equals to 1 and x is equals to minus 2 are the roots. How can we say that they are roots? He has used the word called as vanishes. Vanishes in the sense it becomes 0. So, let us suppose think that x is equals to 1 is the factor. 0, that means root of the equation, then x minus 1 is the factor. X is equals to minus 2. That means x plus 2 is the factor. Now, we are going to get, when you multiply, we are going to get quadratic polynomial. So, we should get cubic. That's why I am taking the other term as, other factor as ax plus b. We don't know a and b values. So, we are going to get the quadratic polynomial. Now, the condition they have given. What is the condition? Has the value of 4 and 28 when x is equals to minus 1 and x is equals to 2. So, whenever you are substituting x value as minus 1, then we are going to get the value as 4. And whenever you are substituting x value as 2, we are going to get the value as 28. This is the condition they have given. Now, based on this, let us substitute the x value in the given assumed values, assumed expression. X is equals to minus 1, minus 1, minus 1, minus 1 plus 2, ax plus b, a into minus 1 plus b. Its value is going to be 4 because f of minus 1 is equals to 4. Now, minus 1, minus 1, minus 1, minus 2, here 1, minus a plus b equals to 4. Now, minus 2 into minus a plus b is equals to 4. Now, multiply with minus 2. 2a minus 2b is equals to, or you can simplify directly. 2 value you can send there. Minus a plus b is equals to 4 by minus 2. That means minus 2 you are going to get. So, minus a plus b is going to be minus 2. This is one equation. Second one, f of 2 is going to be 48. Sorry, 28. 28 or 48? Yeah, 28. So, again substitute this value. 2 minus 1, 2 plus 2 plus b. It is going to be 28. Now, 2 minus 1, 1, 2 plus 2, 4. 2 into a, 2a plus b is equals to 28. Transpose this one, you will get a 28 as 7 of division. 2a plus b is equals to 7. So we get two equations here. Solve these two equations, we will get the a and b values. Minus a plus b is equals to minus 2. 2a plus b is equals to 7. So going to subtract because b has the same coefficients but opposites, same signs. That's why I am subtracting. B gets cancelled. Minus a minus 2a minus 3a minus 2 minus 7 minus 9. Then a is going to be 3. If a is going to be 3, then what about b value? B is equals to minus 2 plus 3, that equals to 1. So a is equals to 3, b is equals to 1. So this is another example based on this roots of an equation or solution set. So I hope you understand the topic. So next we'll move on to the next topic, which is a remainder theorem and a factor theorem. So remainder theorem says that whenever f of x is divided by a linear polynomial x minus k, then remainder is given by f of k. So what is the meaning of that one? What is the proof for that one? So we said that f of x is a polynomial and it is divided by the x minus k linear polynomial. So whatever the polynomial we have taken for dividing, in order to get the remainder, substitute x value as k. X is equals to k. So then we are going to get the remainder. So what is the proof? So we know that dividend is equals to divisor into quotient plus remainder. What is dividend here? So we are dividing f of x With what we are dividing? With the x minus k. What is the coefficient? We don't know. We are going to get some coefficient q of x and remainder will be r. If we are going to substitute x is equals to k, then f of k is equals to, so x plus k minus k into q of x plus r. K minus k 0. 0 into anything 0. 0 plus r, r. So what is r here? Remainder. So it clarifies the statement. It is given the proof for the evident proof for the statement that whenever f of x polynomial is divided by x minus k polynomial, that is a linear polynomial, the remainder is given by f of k. So this is the proof for that one. So this is called as a remainder theorem. Remainder theorem. So based on this also, so many questions can be posed. So let us take an example. So x cube, anything, any polynomial you can take, any quadratic, cubic or biquadratic polynomial you can take. So x cube plus 4x square minus 7x plus 6 is divided by x minus 1. Find the remainder. So simple question. This kind of questions we have solved in 9th and 10th standard. So x power or x cube plus 3x square plus minus 7x plus 6. Let us think that this is the given polynomial. It is divided by x plus 1. It is divided by x plus 1. Then what will be the remainder? This is the question. So what is the meaning of dividing by x plus 1? The x value is going to be minus 1. So if you consider this one as a polynomial f of x, name this polynomial as f of x, and since it is divided by x plus 1, substitute x value as minus 1. Now fill this x place with minus 1. Minus 1 whole cube minus 1, minus 1 whole square 1, 1 into 3, 3, minus 2 minus plus 7 plus 6. 3 minus 1, 2, 2 plus 7, 9, 9 plus 6, 5. So f of minus e is going to be 15. That means when you divide this polynomial with x plus 1, so we are going to get 15 as a remainder. So that is one example. Next, after this remainder theorem, we have factor theorem. This factor theorem is a typical or special case of remainder theorem. So, what does the factor theorem states? It states that if f of x is a polynomial and it is divided by the x minus k polynomial, we are going to get the remainder. That is a remainder f of k. If that f of k is going to be 0, then whatever the polynomial we have taken for dividing, that is going to be the factor of this one. Once again, f of x is a polynomial. We are dividing a polynomial with x minus k and we are going to get the remainder as f of k. If this f of k is going to be 0, then x minus k is the factor of this polynomial. So proof. What is the proof? Same condition. F of x is equals to x minus k into q of x. This is r. Now r value is f of k. X is equals to k, you substitute k minus k, q of k, and r value is going to be f of k. Already we have proved this one. If this f of k is going to be 0, or let us suppose think that x minus k itself. Okay. R is equals to f of k. From where we got this one? From a earlier proof. If this f of k is going to be 0, then x minus k q of x. That means we can say that f of x is equals to x minus k into q of x. That means When you multiply these two numbers, that means two polynomials, we are going to get the given polynomial. So here x minus k is the factor. So based on this also so many examples, so many questions are arising. Let us discuss one. So they are given that x square plus x minus 6 is a factor. You can see this question on the screen. What they have given? They are given x square plus x minus 6. X square plus x minus 6 is the factor of 2x power 4 plus x cube minus ax square plus bx plus a plus b plus not plus minus 1. Yes, minus 1. So this is the polynomial. This polynomial has the factor of this one. What is the degree of the polynomial? Biquadratic polynomial. 4 is the degree. Here degree is a 2. So if you factorize this one, you are going to get a 2, 0. That means 2 roots of the polynomial equation. So that means 2 more are required to find out. No need to find out 2, but we have to find out a and b values here. So let us consider the first one, x square plus x minus 6. If you factorize this one, we are going to get x plus 3 and x minus 2 as the factors. How to find out the factors? You know, last term should be multiplied with the first term, minus 6x square. Choose the factors of minus 6x square such that on adding you are going to get the middle term. So 3x minus 2x. So with that notation we got x plus 3 and x minus 2 as the factors. So what is they have given in the question? Find the values of a and b. So let us name this polynomial as f of x. Since we know that x plus 3 and x minus 2 are the factors, substitute directly. F of minus 3 is going to be 0 because it is a factor. F of minus 3, if x plus 3 is a factor, then f of k is 0. This is the condition. Now x is equals to minus 3 I have substituted. Now here 2 into minus 3 whole power 4 minus 3 whole cube a minus 3 whole square b into minus 3 plus a plus b minus 1 and equated to 0. Minus 3 whole power 4, 3 power 4, that means 81. 81 into 2, 2 1s are 2, 2 8s are 16. Minus 3 whole cube, minus 27. Minus 3 whole square, 9, 9a. Minus 3b plus a plus b minus 1 equals to 0. Now, whatever the values we are having, just simplify that. 162 minus 27. How much? 5, 35. 135. 135 minus 1, 134. Minus 9a, minus 3b. Let us directly add them because like terms are there now. Minus 9a minus plus a, minus 8a, minus 3b plus b, minus 2b. Minus 1 equals to 0. No minus 1 now. Already we have simplified this one. Minus 8a minus 2b is equals to minus 134. Minus is common and 2 also common. We can write it as 4a minus b is equals to 2 6 are 12, 2 7 are 67. So this is one equation. Again, when you substitute x is equals to 2. So we are going to get f of 2 equals to 0. So that means 2 into 2 power 4, 2 cube, 2 square, 2 a plus b minus 1 equals to 0. 2 power 4, 16. 16 2s are 32. 2 cube, 8. 2 square, 4. A, 2b, a plus b minus 1 equals to 0. 32 plus 8, 40, 40 minus 1, 39, minus 4a plus a minus 3a, 2b plus b, 3b is equals to 0, minus 3a plus 3b is equals to minus 39. Take minus 3 common, a minus b is equals to 13. This is the second equation. Solve these two equations, we are going to get a and b values. 4a minus b is equals to 67. A minus b is equals to 13. Eliminate this any one variable, subtract. B gets cancelled. 4a minus a, 3a. So 67 minus 13. 4, 5. So 3 ones are 3 8s. That means 18. If a is going to be 18, then b is going to be 15. 15 or 5? Sorry, 5. So b is going to be 5. So this is how we have to solve the problems related to factor theorem. I hope you understood the concept. Let us move on to the other concept, which is called as identity of an equation. What is an identity? Identity nothing but it is an equation which is true for any real values of its variable. Suppose we have learned the variable identities like a plus b whole square, a square plus 2ab plus b square, they are identical. For any values of a and b, both LHS and RHS are going to be equal. Similarly, sin square a plus cos square a we have learnt in trigonometry. So for any values of angle a, sin square a and cos square a is going to be 1, which will be true for any values. Similarly, 5 into x minus 4 is going to be 5x minus 20. For any value of x, it is going to be true. So this is the concept of identity of an equation or identity equation. So we are also having identity inequation. So these are called as identity equations and inequations or inequalities. What is the meaning of inequalities? So x square is greater than 0. For all x values, for all values of x, this statement is going to be 0. Or you can take x square is greater than or equal to 0. So we call it as inequation. Similarly, a square minus 1 is greater than 0. So this is also one statement. For what value of the a square? For any values, or you can take a square is greater than 1. If you take any value of x or not x, a. So a square is greater than or equal to 1. For any value of a, it is going to be true. A square is greater than or equal to 1. So these are the some identity equations and the inequalities or inequations we can call it as. Now after this one, graphical representation or graphical interpretation of 0 of a polynomial. So already we have come across in the starting definitions or basic concepts of linear polynomial, quadratic polynomial, how the graph is going to be represented. Apart from here, we have seen that any linear equation, after drawing we are going to get the straight line. It is a linear equation or linear polynomial. Similarly, we have quadratic polynomial and cubic polynomial. biquadratic polynomial. It is a quadratic polynomial, cubic polynomial, biquadratic polynomial. Now, based on this also, some questions will be asked. Not to say that how many areas they are touching. They will give an equation and say that for where the graph will touches the x-axis, or where the curve will not touch the x-axis. Let us take one example. It states that in how many points, we can see the question on the screen. In how many points graph of y is equals to x cube minus 3x square plus 5x minus 3 intersect the x-axis? Question is that y is equals to x cube minus 3x square plus 5x minus 3. In how many ways? You know that it is a cubic polynomial. It touches the x-axis generally at 3 points if it is a cubic polynomial. But for this polynomial, for these variables, for these coefficients, what is the graph? Whether it is going to touch at 3 different places, we have to tell. Now, in order to solve this one, first we know that we should know that what is the zeros of the polynomial or roots of this polynomial equation if it is an equation. So what is that one? We have discussed one note point. Sum of all zeros. What are the sum of all zeros? 1 minus 3 minus 2 plus 5, 3. 3 minus 3, 0. That means sum of all coefficient is going to be 0. Then x minus 1 is a factor. Then x is equals to 1 is the 0 of this polynomial. Take all the coefficient using the Horner synthetic division method, solve this problem. Make it as 0, 1 into 1, 1, minus 3 plus 1, 2, 2 into 1, this is minus 2, minus 2 into 1, minus 2, 5 minus 2, 3, 3 into 1. So this is going to be the quadratic equation. Now, quadratic polynomial. Now, for this polynomial, am I going to get any real coefficients or real values of x value? No. We are not going to get a real values of x. Because of that reason, we can say that it is going to touch the x-axis at only one point. That is x is equals to 1. Because we are not going to, because you can check 3 into x square, 3x square, choose the factors of 3x square such that we are going to get minus 2. We will not get such factors. So because of that reason, we can say that x is equals to 1 only the place on the graph where we can see that graph is touching. So we will get some points on the graph which will not touch x-axis but only will get imaginary values. So okay, so that is the kind of problems they are going to ask. So I hope you understand the concept in this video. So in the next class we are going to come with some more topics.